This question is from GATE 2016, Mechanical Engineering Paper Set 3, question number 38. A bolted joint has 4 bolts arranged as shown in the figure. The cross-sectional area of each bolt is 25 mm square. A torque T of 200 Newton meter is acting on the joint. Neglecting friction due to clamping force, the maximum shear stress in a bolt is dash megapascal. Let's look at the arrangement of bolt and see how the torque will be distributed. Observing the direction of torque, we see that force on the bolts will be like this. Forces on all 4 bolts, the direction is shown because it should produce, when looking from this side, these forces should produce a anti-clockwise moment. So that is done. We have correct direction of the forces. Let all the forces be F1, F2, F3 and F4. Torque in general is given as force into radial distance, that is R. Now diameter of this circle, the dotted circle, is given to be 100 mm. That means its radius will be 50 mm, and that is nothing but the radial arm or the radial distance R. We have radial distance to be 50 mm. And because the torque value is given in Newton meter, we'll convert this into meter. R is 0.05 meters. So in order to find the forces on all the bolts, let's first find the equivalent force that this torque will produce. We have T by R. T is given to be 200. R is 0.05. So the total equivalent force that the torque will produce is 20,000 by 5, which is 4,000 Newton. Now every bolt is situated at equal radial distance, and that is why the force will be equally distributed among all the bolts. Therefore, we have force on each bolt F1 equal to F2 equal to F3 equal to F4. Let all the values be equal to F, and F is nothing but 4,000 divided by 4, which is simply 1,000 Newton. Now we have force that is acting on the bolt, and this force acts as a shear force, shearing force. So to find out the shear stress on the bolt, all the bolts will have equal shear stress because their cross-sectional areas are equal and force on them is equal. So all of them will have equal shear stress, and that will be the maximum shear stress on all the bolts. Maximum shear stress is equal to force to be resisted by the bolt divided by the area that is resisting this force. So we have force is 1000 Newton divided by area is 25 mm square. So let's put it 25 itself because we want the answer in megapascal, and megapascal is equivalent to the unit Newton per mm square. So we'll keep it as it is. We have the answer to be 40 megapascal or Newton per mm square. Let's fill in the answer. Maximum shear stress in a bolt is 40 megapascal. To learn more about threaded fasteners or bolts, rivets and other joints, you can refer to the NPTEL video Lecture 17, Design of Threaded Fasteners, from the course Lecture Series on Design of Machine Elements 1 by Professor B. Mehti. He is from Department of Mechanical Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.